Good evening, everyone. Today we are going to discuss about AI. What are the job prospects? How you can become one? What are the resources that are available that you can use to become AI enthusiast or a AI expert? So we have to start out with the very basics. So within the AI field, there are multiple areas, subdivisions that you should be knowing about. So AI you can think of as an all-encompassing field that has components such as machine learning. It also has something known as data sciences, and it is very important that we understand what all of these are and how they basically relate to each other. So let's start with machine learning. So machine learning is primarily used interchangeably with data sciences. Machine learning in particular is the ability of a machine to learn from certain examples and being able to predict certain outcomes. Now, when I use this word, it will sound very like interesting. Like, what am I even trying to say here? So I'll have to use an example to explain what machine learning entails. So machine learning, if I have to broadly classify, there are two areas within machine learning that are broadly used across industries, and people are very well aware of them. There are other areas also that are much more complicated and more recent in nature, but two areas are very fundamental, which have been used for ages. So they're broadly classified into two areas. One is known as uh, supervised learning, and the other area is known as unsupervised learning. So in the supervised learning, the idea is it is further divided into regression and classification. And within the supervised learning stage, idea is that you would be given samples of training data with a predicted label, and based upon that, you will basically train your model. Once the model is trained, it will be given examples, and now you have to predict the label. So think of like weather prediction that you see all the time, right? They say that tomorrow it will be raining, it will not be raining, or they also say tomorrow the highs will be like 35 degrees centigrade, or lows will be 21 Fahrenheit, things along those lines. So whenever we try to predict or forecast a number, more likely it is going to be regression. Whenever we are trying to predict a class, let's say high or low, yes or no, or high, medium, low, things like that, then it would be most likely classification. I'm oversimplifying things just for this session, but I'm just trying to give a basic essence of like how these things work. So how you would be able to do for a weather is that you will collect a lot of data from the past, say last 5 to 10 years, and there will be a lot of features that determine whether it will rain tomorrow or not, which could be what is the pressure, what is the humidity, what is the wind system looks like, are there any kind of new kind of storms, etc., brewing nearby. And based upon that, you predict, will there be a cloud formation, and because of the cloud formation, is there a likelihood of rain or not. And you use those examples from the past whenever such kind of systems occurred. Did it rain or not? And if you foresee that in the coming days or tomorrow, in the coming week, essentially similar set of systems are going to form, which have high likelihood of rain, you make a prediction that it can rain. And these are the chances, this is the confidence level, that 50% chances of rain, 20% chances of rain, or 0% chances of rain. So that's a typical class binary classifier. Similarly, when they predict that the high today will go to, let's say, 90 degrees Fahrenheit, and the low will go to 55 degrees Fahrenheit. This is a specific number, right? And this is generally done through regression, because maybe it doesn't go to 90, it goes to 95. Maybe it only goes to 88, the highs, and the low maybe goes to 32, or maybe the low goes to 45. So there could be some variability there, but you are within the range, right? You predicted 35, then it kind of closed at 40, maybe 32. Same way you predicted 88, it closed at 90 or like 85, so you're still close. But This is more closer to regression. Now, as you can tell, right, it's not easy for everyone to get into this because either you should have a background in computer sciences or you should have a background in mathematics. It's important that you may also have a background in statistics. All of these areas are a good fit for you to become a machine learning engineer, right? So, this is what a machine learning engineer would do. Now, a lot of people also use the word of data sciences. And in data sciences, not only would you be building prediction models, but you also have to be able to, store the data, choose what features have to chosen to build a right model. You have to also choose the algorithms. Now, algorithms also have a variety, right? So we are talking about classification. By far, this is the most used technique across the industry where you need a labor data. And whether it is insurance industry where you have to predict the likelihood that this person is a risky driver, or likelihood that there will be theft, or likelihood that you will fall ill, all those things will determine your premium. So a person who is not likely to fall ill or is a younger person generally have lower premiums, and people who are elderly in age or already have pre-existing diseases have higher premiums because the risk for them to fall ill is much more higher, right? So those are the areas where you use machine learning to predict what should be the premium. Same way, you look at any kind of ads that you see on the website, or like go to any e-commerce or social media website or an app, anything that you open up, you will see a lot of ads that are targeted towards you. And these ads also, the back are highly personalized towards you, who you are, what you have done in the past, have you in the past clicked on certain things like that or not. Those are the ads that you'll likely show. And again, it is used through, these are targeted to you through machine learning. So it's basically everywhere, right? So whether you understand it or not, or whether you know it or not, even the content that you see, like when you go to YouTube or when you go to any kind of things, even the content that is being recommended to you is basically based upon machine learning. Now, as you would have understood, right, that you need to have a strong background in mathematics, or you need to have a strong background in statistics or computer science to get into this machine learning field. So, what about others, like who may not have that background? Can they enter into machine learning? So, to simplify that, I'll actually divide it into two parts. For again, so if you look at it, machine learning as a whole is a very, very technically intensive area. So if you are working on application of machine learning, I call it as applied sciences or applied data sciences, then a person who probably knows Python, maybe knows R, maybe knows some programming, and is able to use certain tools around, like libraries around Python or R, can actually work in this field. So as long as they know how to write a software, or they are a data engineer, they're familiar with Python, they know how to use sklearn or TensorFlow and other kind of libraries that are available in Python or Scala or in R, can actually make predictive models as long as they understand the basic fundamentals of machine learning, such as classification, regression on the supervised learning side, or clustering on the unsupervised learning side. I am not going to go into detail, but clustering is an idea where you don't have predefined labels and you still have to find clusters of similar objects, is known as clustering. So again, basically a person who understands programming or knows some programming language and can pick basic concepts of how a machine learning model is built can actually enter into data sciences field, as long as they are working on applied data sciences, meaning that they are not going to invent a new machine learning algorithm, but they are going to leverage an existing algorithm to build machine learning models, right? Which is what majority of the people do. So that's that. Now the question would come in, like, what is generative AI, right? A lot of people have started using generative AI. They talk about LLMs, and as such, and are very interested in like Chat GPT. Like, what is it? So Chat GPT is a application of large language models. So think of it as a subdomain within the artificial intelligence area known as natural language processing, whereby we try to understand how humans communicate with each other, which is either through voice or through written communication. We write it in natural language. In this case, I'm speaking in English, so this is my natural language at this point of time. So for a machine learning model to be able to understand the natural language and predict basically what next sentence I'm going to speak or next word is going to I am going to utter from my mouth, could be like a natural language prediction model. So typically a large language model is also mimics the same. So there is a concept known as transformers, that is the bedrock of any large language model. They basically train on the publicly available data on the internet, and using transformers, they build this large language model. What the transformer does is that uh, whenever you send it a new like request, for instance, you can ask a question that, hey, where can I find courses on machine learning which are free on the internet, right? That would be a question. You would think like this is almost like search, right? On the search also we do the same thing. We can write keywords and it will throw you the answer. So what's the difference between a generative AI and a search engine, right? So the only difference here is that in the search engine, it is going to find a document or a set of documents from an index that has already been predefined. So in a search engine, basically, you can ask the same question, you can write it the same way. What it is trying to do is that it is trying to find out all the phrases and the keywords that you have used in your search, uh, expression, and match it to the documents it has built up in this index. And based upon your search items, it will throw you the document or set of documents, right? You will get a rank list of like top 10, results that would have some of the keywords that you have basically typed. That's how a search works. In generative AI space, rather than looking at an index of documents, it tries to generate the result for you, right? How does it generate it? Basically, in a large language model, it already has several documents that it has read, trained upon, and based upon the sentence that you ask from its own knowledge base, it is generating a new text information from the already cooked up text that it has done during its learning phase. So that's the fundamental difference. So now, uh, one major difference here is that while generative AI generates new content, search engine is only retrieving the existing content that exists out there, and search is not generating the data as such. All it is doing, it is passing you the links where this generate data might be available, the things that you're looking at. Whereas generative AI actually generates the content, and it may or may not share any kind of links. And in generative AI, at least for now, it will only give you one result, which it thinks is the right result because it's a question answer format. Whereas in the search, you will be given like hundreds and thousands of results. Maybe they may be ranked in one order. So that's the relative difference between the two. So machine learning is also used in search. Please don't confuse that it isn't. And a large language model is already like deep machine learning because it uses transformers, which are basically based upon neural networks. So it's already another space of like AI, which is deep learning. I didn't talk about it. So in the end, probably I'll summarize like what are the different areas within the AI space. But this is where the generative AI is. And Chat GPT is one of the tool that leverages a lot of large language models under the hood that helps you basically connect with a chat gpt module wherein you can ask its questions and it gives you a response in the back, right? Again, it is backed by a large language model. Now people start talking about prompt engineering, right? So when you talk to a like a chat gpt or a bot, they call it as a prompt. Whenever you ask a question, there is nothing special about it. It's just a way to ask a question. That's what they're calling it as a prompt. Nowadays they use various techniques to basically make the answers much more personalized and suitable for you. So they call it as prompt engineering. So there is a idea that if you just ask it like a single question, then the response may not be good. But if you basically give it some examples that these are the some of the questions that I'm going to ask, and this is the kind of answer I'm expecting, and then you ask the question based upon the examples that you have given, likelihood of getting a right or a better answer is very high. So they call it as prompt chaining kind of a thing. So for instance, from a large language model, rather than just asking, hey, what is the capital of Washington? uh, you can ask it like this: hey, chat gpt, or hey, llm, capital of New York is New York City, capital of United States is Washington DC, capital of India is New Delhi, what is the capital of Italy? So basically I have given three examples in the same narrative format where I'm trying to ask a capital. In these three examples I have already shown the capital of those states or countries is the answer, and finally I basically ask the question. Then the likelihood of chat gpt or any kind of an llm giving me the right answer becomes very, very high, because now it has understood the format in which I'm asking. It already knows what the question is and what the answer is, so the likelihood of giving the right answer is high. So in this way you are training the chat gpt, like sub training the chat gpt, or fine tuning the chat gpt or an llm to answer your specific questions, right? So that's where it is. Now the question is that can you basically join this thing? So learning a prompt is easier than learning a programming language, that's given. So even people who may not be from, like I talked about, mathematics, computer science backgrounds, or statistics backgrounds, people from arts, literature, etc., who understand this basic concept that you can basically prompt a bot, a prompt like a llm or a chat gpt to basically answer your questions, right? You can prompt it to, hey, create me a lyrics, write me an essay about dog. You can do as you deem fit, and the idea is that it will generate you the appropriate answer. So maybe the better prompt that you are going to generate, right? Hey, you can talk it like this: hey, Chat GPT, create me an essay about AI. The essay should have 5 paragraphs. It should be at least 1,000 words long. And the way you generate it, it should be targeted towards, students who are trying to get into AI. So if you give so many informations and give it much more points specifically, that how long it should be, how many paragraphs it should have, most likely the result that you are going to get will be closer to what your requirements are. But if you will just give a free flow thing, hey, chat GPT, just create me an AI essay, then basically we don't know how the answer might look like or what exactly the contents might be. So that's the kind of a difference. So yes, if you are trying to become like a prompt engineer, chances are that you don't need to have a background. But my thinking is that essentially, if you basically are becoming a chat engineer and you so prompt engineer sorry, my bad, then knowing these nuances around that, even to ask questions from a bot, you have to frame it in a fashion that it basically responds back in a fashion that would be actually relevant to you. Now, as you have understood, the large language models are now becoming multimodal, meaning that now you don't even have to train them just based upon the text. You can do it in the voice, video, audio, images, all the kind of rich media you can basically supply to it, and you can generate, voice, video, audio, art, text, any kind of output basically. So it basically makes creative work, like a lot of people who want to publish articles or who want to author videos or audios, etc., can use certain large language models such as gtp 4, 4.5, or Gemini model from Google, to generate creative content, right? Not limited to just text but also other kind of medias. So that's quite possible, and you don't need to be like a trained engineer or a mathematician, or even like a statistician to be able to use these tools, right? So I would say there are three levels of expertise that is needed. So if you build fundamental data science or fundamental machine learning, I'm again going to use the word fundamental here. That means that you're evolving the field of data sciences or evolving the field of machine learning, which means you are actually researching on new algorithms. So let's say Google initially came out with the paper for transformers. So that's a new innovation within the field of data sciences, right? So here you need PhDs and a lot of research in fundamental data science to be able to come out with a new algorithm to do certain thing. That's That's one thing. So here you need a lot of expertise in that area. So maybe a lot of mathematics, statistics, very good understanding of machine learning and data sciences. So this is not for everyone. So it is very clear that you have to have several years of experience in the field. You have to work on the cutting edge. You need to really understand matrix multiplication, integral and calculus. You need to understand statistics really well. You need to understand computer science really well to be able to come out with such kind of algorithms. So that's a field of study, and a lot of companies such as Microsoft, Google, IBM have their research labs that are solely focused on machine learning research. So they will do that kind of thing. OpenAI also does that. Now, the second field is applied data science, which is where a lot of companies such as Amazon and Google and Microsoft and every other company uses that. Applied data sciences is that somebody else has already created these frameworks or models, etc., but you're using them to apply to a business problem, right? This could be advertising problem, a search problem. This could be insurance codes, or it could be targeting ads and things along those lines, right? So here, as long as you are like a software engineer, you know some Python, some R, maybe Java, etc., you can use these tools that are already available, such as SageMaker or Vertex on Google or Azure ML Studio on Microsoft, or just basic your Python and R. They have several libraries for machine learning, which will help you build machine learning tools and products and models and things like that. So here, as long as you are a software engineer or a data engineer and have basic understanding of how a machine learning process works, like understanding what is a classifier versus what is a clustering algorithm, what is regression algorithm, as long as you understand those fundamental things, you would be able to build a machine learning models. And the last area is prompt engineers. Here you don't even need to be a engineer or person who understands Python or any programming language. All you need to do is understand like how to write better prompts, what is prompt chaining, and how to converse with a bot or an LLM in such a way that you can generate the output. So this is the most simplistic form, right? And a lot of people can become prompt engineers without basically going through any courses or things along those lines. So my suggestion to all of you out there who are trying to build a career in AI, because there is just too much talk about AI all across the world. People are getting crazily scared that AI will eat up everybody's job and it will be very very challenging. So I'm just using plain language, layman's language. I thought I'm trying to be dumbing it down as much possible so that most of the people can understand. But the idea here is that if you really want to be pioneer, you really want to really get into the nuts and bolts of data sciences, then you definitely have to go for a engineering degree, possibly go for a PhD in AI, primarily in the big tech area, such as Google, Microsoft, Meta, OpenAI. Such kind of companies are investing in these areas. Even IBM and HP and other companies as such, where you have to go deep in the research, do fundamental research and come out with new algorithms and come out with new paradigms of machine learning. So that's one area where you can focus, but again it takes a lot of effort and energy. If you are not solid in mathematics, statistics, I would not advise this area for you. Second area is applied data sciences, which is what has the maximum application. So insurance industry, real estate industry, financial industry, e-commerce, search, everyone uses applied data science, because you just use existing machine learning algorithms that already exist out there and use them to basically build business models or decision models that are required to predict forecasting for, let's say, revenue forecasting for stocks are going to go up or down, or recommending you ads, or recommending you emails, or recommending you stories to read, or recommending you videos. All those things are application of machine learning, is known as applied data sciences. So technically data engineers or software engineers, etc., can pick this field and start working on that area. Last is the prompt engineers, which basically doesn't require any background in any kind of engineering or mathematics or data sciences, etc. As long as you can write the right prompts against chat gpt, you can basically generate content, etc. So as far as education is concerned and the courses are concerned, I would say that there is a lot of hype right now. So people who have some background in AI or can demonstrate that they have worked with some generative AI tools, etc., have a higher ability to attract certain jobs, even in tech and non-tech industries as well. Lot of those jobs could be in creative industries like animation, content generation, newspapers, media houses, or film generation, etc. They're using a lot of generative AI nowadays, so there is a high likelihood that you can get jobs in those areas. And I would say before you get into those kind of jobs or try for those things, look for content online. There is a lot of free courses that are available. All you need to do is just go on Google, search for a free course on generative AI, or just go to blog sites of all these larger companies like Microsoft, Google, Amazon. All of them have case studies, blog posts that will help you basically learn what are the basic principles of generative AI, or basic principles of ML and data sciences, etc. So you don't even need to actually pay for any of these courses. These are freely available. All these bigger companies like Microsoft, Google, Amazon, Meta, etc. publish their blogs. You can read through it, learn it. So all I will say is that there is a lot of information that is already available out there. You don't have to pay for these courses to learn certain things. So if you are motivated, if you have energy, and if you have passion, and you really want to do something in this industry, I'll recommend you go to all these bigger companies. You know their names. Like, these are the same companies who are laying off people right now, and giving excuse that because of AI they're laying off these people, which is untrue at this point of time. But I think it doesn't harm anyone to go and basically read about them, build their skills in this area, so that they can put it in their resume that they also know, let's say, prompt engineering, which is the easiest thing to do, right? And you can try it out, right? There are a lot of free tools already out available right now, where you can try your skills. So easiest is prompt engineering, then the second step is applied data science, and the third step is basically fundamental data science. So for applied data science, you do need some background in Python or R. So basically, a software engineer or a data engineer uh, is required to be able to do that. Um, Fundamental data science, you would require even more sophisticated focus areas, maybe an MS or a PhD, or a very solid computer science undergraduate degree with focus on mathematics and essentially statistics would be highly recommended. But for prompt engineering, I think you don't need much of an educational background. Anyone can basically get into that and try it out. So from a career perspective, I think because there is so much hype about AI right now, especially in the generative AI area, for a few foreseeable future, you will see a lot of jobs around prompt engineering, or people talking about building LLMs or using LLMs. Majority of the jobs that you will see are using LLMs by prompting. They're not building LLMs, right? Unless you are in the open AI division that builds LLM, or a Meta team which is building LLM, or a Google team that is building LLM. Most of the jobs that you will see are using LLMs. So they want people who have used LLMs, and which will require either better prompting, or they're looking for data engineers or software engineers who have played with different large language models and use them in their workflows. That's what they're looking at. So please do not confuse when you see jobs of LLM. They're looking for applied data sciences, a person who has worked with LLM, not built the LLMs as such. There will be jobs that require you to build the LLMs as well, but there they will require a solid understanding of, as I said, mathematics, computer sciences principles, and statistics. So that may not be a good fit for everyone unless you have those backgrounds and have worked in those companies. The second set of jobs wherein they are requiring you to use LLMs and build software along those lines requires a software engineering skill, probably a data engineering skill, having worked with some data sciences, etc. So this is for those kind of engineers. And last is the prompt engineers, which is the most simplest form of things, which is more creative field, and there might be jobs around that as well. So in this coming year, I would say in 2024, there is a likelihood that you will still see a lot of those jobs, and people who have AI or generative AI or some kind of prompt engineering experience may have a little bit of a leg up, especially if you do a lot of projects, and if you can list those projects out there that, hey, I did these kind of things. Chances of you attracting that job are a little bit higher than a plain vanilla resume who does full stack or data engineering, etc., without any kind of AI and ML. So I'm not going to say that you will not find any job if you are not having AI and ML, because it is like saying a wrong thing. There would be things there as well. But if you want to catch on to the hype, if you want to jump on this hype train, we don't know how long this hype will remain. My doubt is by end of this 2024, people will stop talking about generative AI, and things would have settled. That doesn't mean it will go bust. It's just that it will not be so much hyped around, right? Since it is new, and a lot of layoffs also, companies have been using the name of AI again and again. That is why it is coming again and again. My assumption was in 2023 itself it will die down, but because of these layoffs and people claiming that these layoffs are due to AI, again it is propping up again. So I think maybe a little bit of more noise we will hear about generative AI, etc. So it doesn't hurt to add that as a part of your skill set. Learn it through open, technologies that are available. There are a lot of free content online. All the bigger companies, big tech companies, have courses which are free of cost. Anyone can go on to their blog post and learn through them. So I'll recommend that. There are a lot of people who publish courses which are paid and all. I'll recommend not to go for them. I don't do any courses as well, and it's super easy. Like if you're passionate, if you can read content that is out there already on different companies website, that would be awesome. Use that and you can upskill yourself and try to gain certain AI skill sets, etc. So now I'll summarize and just rephrase the whole AI concept. So AI is at the top layer. It is all encompassing artificial intelligence. Okay. Within the AI space, there is data sciences. So data sciences is anything to do with data mining, data storage, data management, and building machine learning models. Under the hood is machine learning. Machine learning is the field where we talked about classification, regression on the supervised machine learning side, and clustering on the unsupervised machine learning side. Some examples, algorithms of classification and regression are logistic regression, support vector machines, decision trees, etc. On the clustering side, we have Cohen self-organizing maps, k-means clustering, which are very kind of well known algorithms. Then people talk about deep learning. This is goes further down below. Deep learning means that when you work with basically neural networks, then we call it as deep learning. It generally requires working with huge amount of data. It is still machine learning, but we call it as deep learning because it is used neural networks, and commonly used neural networks are basically recurrent neural networks, or RNN, or convolutional neural network, or CNN, which basically people use. CNN is mostly used with images, and RNN is mostly used with text. Within that area, there is something known as NLP, natural language processing, which is where all the hype train is going. LLMs are also kind of a natural language processing, and within the natural language processing, people used RNN. Then they came out with LSTM, which is long short-term memory, and which was further promoted by Google to come out with transformers. And ChatGPT is also a kind of a transformer, right? Generative pre-trained models. So that's the GPT, basically full form. This is still like NLP area, and generative AI field is again a subsection of the overall big scheme of things that we talked about. Generative AI is always focused upon predicting the next word or next content, next audio, next video. It's still prediction, uh, but it is generative in the nature because you are generating new content in this prediction. It still fundamentally follows the same. The AI is the bigger umbrella. Within the AI, we have the data sciences. Within the data sciences, we have the machine learning. Within the machine learning, we have the deep learning. Within the deep learning space, we have the NLP. Within the NLP space, we have the transformers, we have the GPTs, so on and so forth. So now all these LLMs and the generative AI field has become much more bigger, because now we are not limited to just the NLP side of the things, but we also have the art, audio, video, all kind of content, all kind of multimodal content is being worked upon, and you can generate any kind of multimodal content. So hopefully this video would have helped you understand like how to think about your careers, what are the job prospects that are available, what kind of background and qualifications that you require to take on these job prospects. So yes, AI will be remaining important. There will be some hype still, and it doesn't hurt to add those skill sets to your portfolio or your resumes. Go search online, you'll find a lot of free content that is available. Don't join paid courses. I am basically against any kind of paid content or course. You can find freely available courses. All you need is your own motivation, and as long as you have the motivation, you can find them. As I said, go search Microsoft, Google, Amazon, Meta. On these four companies' blogs, you will find a lot of content on machine learning. They will have step-by-step instructions on how to become a machine learning engineer, or how to use a generative AI, how to become a prompt engineer. You can do that on their website. They will have far better content than any other content that you can find. Of course, Khan Academy and other freely available contents are also out there, so you can learn about that, and go from there, and add those skills to your resume. uh, as I said, jobs currently are going to be very selective, but having that extra edge of AI will definitely give you some boost, if not more. But again, don't have very high hopes, like it is just upskilling yourself. But when the right opportunity strikes, and if you are already equipped with those additional AI or prompt engineering and those kind of capabilities, maybe converting to a new job might be much easier. By no means take this word saying that if you learn that you'll guaranteedly get a job. I'm not making that like suggestion here. What I'm just saying is that since the courses are already freely available and anyone can basically upskill, and for prompt engineering you don't even need any background in computer sciences or mathematics or anything like that. So why not just be equipped with knowledge, and when an opportunity strikes, just bounce upon it and make it happen. Hopefully you like this video. This is a new year, we are sitting on a weekend here in the US. I'm hoping that you are enjoying this content, and probably you can share this content with other folks as well. If you like what I have shared today, please comment upon it. Do subscribe and like what I have been stating here. Do share it with your friends and within your network. Do write and let me know, is there any other topic that you would like to listen into, what I can cover, so that when the next time you log in, you can basically check that content as well. Take care, spend time with your family, enjoy your time, whatever you have. Enjoy the winters as the winter season is going on. Eat healthy, keep calm, exercise, and have a nice day and the nice week ahead. For now, I'm signing out. Have a nice day. Take care and bye. Hope to connect with you soon in a new session.